We have multiplied polynomials in the first part of this unit, and now we're going to go backwards. It's like dividing. It's called factoring. So let's look at what factoring is. Factoring is the process of rewriting a polynomial as a product. Product is the situation when you're multiplying things of two or more polynomials. And it's those polynomials that you rewrite it as products of are called factors. So we think of it like dividing. So you've factored before and you found factors of a number. So let's review that. What are the factors of 32? Well, 1 and 32. Remember doing this, 2 and 16, 4 and 8. And I can't think of any others. So remember how you listed all the numbers that would go into 32 evenly. Let's do that for -9. So we could do 1 and -9. Actually, I'm not going to try to write it this way. This is not going to work. So we could do 1 times -9, -1 times 9, 3 times -3. Those are the only factors of -9. So let's look at factors of a variable, of a monomial. What are the factors of x to the third? Well, x and x and x. If you factored it, it would be x times x times x. So what could we say? We could say x times x to the second. And that's really all we could say. We could say x times x times x or x times x to the second. And then we have 3x. What are the factors? 3 and x. So the greatest common factor, or GCF, greatest common factor, you've talked about this before too in math, but you haven't done it with polynomials. The GCF of a polynomial is the largest monomial that divides evenly into each term. So the first thing you do is you look at the coefficients. That's the big number in front of the variable. Find the greatest number that goes into each coefficient evenly. Then you look at the variables they have in common. And the smallest degree of each variable, degree is the exponent, right, is your GCF. And then you have to write the GCF in front of parentheses, divide it into each term, and write the remainder in the parentheses. This will be a product that equals the original, and those are called factors. So first, let's just identify some GCFs. What's the GCF? Remember, we look at the coefficients first, of 15 and 9. Well, they both have 3. But look at this. This one has M's, this one does not. So they do not have any letters in common, any M's in common. Let's look at this one. The 5 and the 10 have 5 in common. Now, they both have at least one X, but this one has 3, this one only has 1. So they only have one X in common. And remember up here where I said go to the smallest degree. So since this is 3 and this is 1, 1 is the smallest, that's your GCF. So let's go back to this first example and see, now that we've identified that the GCF is 3, we write it in front of parentheses and we divide 3, the GCF, into each of these. 15 divided by 3 is 5. I didn't change the M's. -9 divided by 3 is -3. So this is the factored form of the original. So I can always check it, because if I did this right, then if I multiply 3 times 5 in second minus 3, I should get what I started with, 15 m second minus 9. Is that the same? Yes. So you can always check your answer. Okay, let's factor out 5x. If 5x is my GCF, I divide it into both of these. 5 divided by 5 is 1. Remember, when I'm dividing exponents, I subtract them. 3 minus 1 is 2. 10 divided by 5 is 2. X divided by x is 1. This is your factors. Now, could I check it? If I multiplied 5x times x second, I would get 5x third. 5x times 2 is 10x. Does that match the original? Yes. Oh, now we have a trinomial. Doesn't matter. We're finding the greatest integer that will go into all three coefficients. So 4, 6, and 14, they have a 2 in common. And then they all have x's. So let's look at the smallest exponent of x, which would be this one, the 1. So that's your GCF. Now, divide 2x into all of them. If it helps you to write the GCF under all of them, you can. You don't have to. 4 divided by 2 is 2. X to the 5th divided by x, you subtract the exponents, and there's 4 left. 6 divided by 2 is 3. X to the 2nd. 14 divided by 2 is 7. The x's cancel. Let's do some that have more than one letter. So this one, -8 and -12 have a -4 in common. Now, they both have a's. The smallest exponent is 1. They both have b's. The smallest exponent is 1, and they both have a c second. So when I divide this, I get 2a, because the bc squared cancels, plus, because -12 divided by -4 is +3, the a's cancel, the c squareds cancel. There's just a b left. And if you're not sure you did it right, you can multiply through and check your work. I think I'm going to do the last, this example and then stop. So they all have 4. No, they don't all have an x. The x cannot be part of the GCF if even one of the terms doesn't have an x. They have to all have an x, or it's not common to all of them. Do they all have a y? Yes. What's the smallest degree of the y? 1. Now divide. You are left with an x squared y minus 2x plus 3. That's it.